So for the new syllabus, this is our syllabus. These two is our syllabus. So you don't need to do it for the current syllabus. Okay, stratified sampling is basically just strata, so we don't need to worry about it. We look at part 3. Actually, for part 3, it's just a standalone question. You don't need the part 1 and part 2, I believe. So the company secretary obtains a sample of 80 employees, right? In order to carry out a hypothesis, believe that the mean age of the employee is now less than 37 years. You are given that the population variance of the age is this guy. Okay, so we are given the population variance. It's not known to be normally distributed. Okay, so we need to use like CLT. That's the main thing, right? So let X be this, then let mu be the population mean age of the employees. I think this is the common knowledge. So this one is known to be 37, right? So H now will be mu. He believes that if you look at this guy here, H1. Okay, we know that in our syllabus we can always write 37 years. Okay. So then you're given that the population is 140 years. So basically this is population variance sigma square. N is 80 . Okay. So right now hypothesis to test the managing director belief, you are given that the result of the test using 5% level of significance is that the managing belief should be accepted. Okay, determine the set of possible value of the mean age. So because this is in order for you to support the managing director's claim, right? This alternative hypothesis has to be the managing director's claim. Because if you put more than 37 years old, right, you're not supporting any claim. So you want this will be less than 37. Okay, so we have n equals 80. I have got sigma squared. This is this one. Then what else we need? Alpha percentage is 5%. Okay, we need to find the set of possible or mean age. So basically need to find the set of when because they say to support H0 is rejected . Okay, this is what we need. So under H0 the test statistic is always a z-test . We use z-test, then after that approximately by CLT, because your population is not known to be normal. If it's not known to be normal, definitely have to use CLT . Okay, so that's the first thing we need to know. So I think just write that down. So I think finding the range of x bar is not an issue. Just draw the standardized curve. Then you need this guy here. The tolerance level is 5%, so you just draw 5% here. Okay, 5%. So you have a z crit here, z critical. Okay, not an issue. So to reject H0, we know that basically z statistic or z calculate or whatever z statistic is less than z critical, at most z critical. Okay, this is always H0 is true . The closer you are to the mean, the truer you are as H0. So here what you do is second distribution inverse norm. So 0.05. Press left. Okay, you get this. From GC we know that z critical will be z crit will be negative 1.6448. So we just do that . Z stats on the other hand, we just need to standardize the x bar. So this will be x bar minus 37 over 140 over 80 . Then this will be at most negative 1.6448. Then multiply to the other side. Taking this guy, multiply by square root 140 divided by 80. Okay, you get this. Then you just add 37. 34.824. That's that. You want the, what do you call it? You want the set of possible value of the mean age . So you just write it down. Age will be 0 bar x to 34.8 3SF. Age has to be positive . You don't put the z. Actually, you don't put this is okay . Shouldn't be an issue. Yeah. The subsequent you're given instead the mean age . of a sample. Now your X bar is this guy. Okay, so you test at alpha percentage level significance should not be accepted. So basically, you don't reject H naught. Okay, you don't reject H naught because now you want it to he supports H1, but basically now you don't want to support H1, so it's H naught. Find the self possible. This one is just using p-value method from GC. Just find the p-value. You know that don't reject H naught will just be p-value. P-value should be more than alpha percentage. Okay, the idea is basically if I got this is my alpha percentage, this will correspond to my z crit. So the p-value is this guy z statistic. Okay, so this is p-value. So if you do not reject H naught, your p-value have to be more than alpha percentage. That's that. Find out what's the p-value. Go to stats, go to calculate test. So G test to stats. Mu naught is you don't need to rewrite the entire thing because it's the same distribution. So you can just put like 37. Mu naught is square root of 140. Then X bar now, because you're given 35.2. Okay. X bar is 35.2. So put this on 35.2. Then the N would be 80. Okay. Then your this one should be less than. You can calculate. That's all. Okay, you get p-value here. Okay, so then you do this. Then after that, you just find the p-value. So we know that H naught is not rejected. P-value is bigger than alpha percentage. You can get alpha is smaller than 8.68. Just write that. Ready. So the thing is, the question is, why do I use the p-value method as opposed to the classical method? Okay, no, usually for p-value, I just key in calculator because it's easier. If you have all the values, right, it's easier to just calculate the p-value. But you can draw also lah. Then you can also find the you can also find the what do you call it, the using the diagram here. Okay, but I a bit lazy, so I just use the calculator. Usually when p-value, I just use calculator. It's faster. Yeah. The question is whether we use this calculate or this draw, right? Yeah, it doesn't it's okay lah. If you want to choose a draw also can, calculate also can. Cause for calculate you will have more SF for p-value lah. For you draw, the p-value may not be so they may not give so much SF, I think, if you put this as draw. So the p-value, you see, it was only 3 SF only. They don't give more than that. Yeah, so you may just